Morning. Hopefully the audio is working for you guys. As you can see, I'm trying a different setup to see if I can improve the audio quality in my bedroom studio. Um, so if you don't hear anything or if it's terrible, let me know and I'll see what I can do. But hopefully this is going to work okay. Good morning, everybody. Good morning to you too. A few of you logged in. There's probably more. Okay, good. So glad to hear it. It's probably not true for everybody, but the more people who get decent sound, the better. Okay, so where we left off was partway through Lab 10. So let me put up a note here about what's going on this week. Okay, great. I'm glad to hear that people are getting decent audio. Okay, so what's going on this week is homework 10 is due. Lab 10. We should complete today, and then Lab 11 to be determined. So we'll figure that out on Thursday, how far we get on Thursday. Today is April 14th. So we'll try. So we'll do, that's what's due. So we're going to start by finishing out the lab number 10 today. And then go over homework 10, and that should be what we do today. And then on Thursday, April 16th. We'll start lab 11 and just see how far we get. Okay, so this is where I left off. Make sure it works okay. So where I left off on lab 10 was I had written the code for the first 3 LEDs of an 8-bit display. And hopefully everyone understands what we're going for, but what we're doing is we have a counter on the processor that eventually we're going to count up and count down. So negative 128, count up to 127, and then turn around and count it back down to negative 128. And what the display is supposed to do is it's supposed to show the present value in binary. Now, because we are limiting our range to between negative 128 and 127, we can represent all of those bits as in an 8-bit LED display. The confusing part is that the register R6 has 8 bits right in a row, and isn't that neat and tidy, and that makes it easy to test those bits. But the LEDs, in terms of programming them, are all not neat and tidy in a row. So we have to write the code to sort of identify the bits in R6 that are turned on, and then map the turned on bits onto our LED display. So we did the first 3, and I've been changing the value, just hard coding it to test my circuit. So let me go show you where we're at. It should be right now that the first 3 bits just flash on and off, because the value is 7. We're not doing a counter yet. So let's just go see if it's true that the first 3 bits are still on and off. I gotta go get the recipe. So I'm taking the recipe, oops. It's going to be messed up. I'm taking the recipe from lab 10. You'll notice that the recipe has changed. So we're not using OpenOCD anymore. We're using a new piece of software called ST-Flash. So we still compile, we still produce an ELF file, but then we have two different steps. And all of the GDB stuff is gone and all of the OpenOCD stuff is gone. So the two additional steps are we take the ELF file and we convert it into a bin file, which is an executable binary for the processor. And then the last step is we use ST-Flash to sort of one-step burn the binary code onto the processor. So we're not playing around with sort of the slow process of OpenOCD and GDB anymore. We're just compiling our code, we're flashing it on the board, and we're running the program to see what happens. So that's why OpenOCD is gone. We don't need two terminals anymore because we're just going to compile ELF bin flash. So there's compile ELF. So this is a new step from the prior labs, bin. And then this is also a new step. So notice no OpenOCD, no GDB. So this last step is going to burn code onto my board. Now I need to plug the board in to get power to it. And you'll see that it's running something from I was grading labs yesterday, so that's someone's code for lab 9. Anyway, so I'm about to write new software, and then you'll notice that the board stopped executing anything, which sometimes happens and sometimes doesn't when you burn new code on it. But when you use ST-Flash, then you always just press the black button after you've finished flashing, after you see the jolly good message down here. Then you can press the black button and see the circuit work. So for me, there's the first 3 LEDs, which is where we left off. So now I'm just going to keep adding tests to see which bits of R6 are set, and then we're going to map those settings into my LEDs. Okay, so let's see, we're going to add this, which would be an R6 value of 15. So up here on my counter, where's R6? Where's R6? Here's R6. For me, it's on line 85. So I'm going to change it to 15, and that's just for the purposes of sort of doing a short step through and test my programming 1 bit at a time. Sorry, I'm getting some Twitch lag, so I'm refreshing my screen. Okay, so I go back up to 85. That's just because I want to control the value of my counter before it starts actually counting up and counting down when I have less control over it. So I'm just going to hard code it to 15, which means that the bits, if I go down to 126 again, the bits in R6 should look like this. So that should turn on my first LED, my second, my third, and my fourth. So this first test, I test the R6 value, and then I toggle the appropriate bit in my display. So notice that this bit of R6 maps to this bit. Now it doesn't look like it, but that's where I actually have to turn on the bit. That is for bit 0 is A5. So that's why that is that way. So this is bit 0, which means that I have to toggle A5 for my display. This one, bit 1 is A6. I'm getting that from up here in the notes, by the way. So if bit 1, 2 to the first in R6 is set, then I need to turn on A6, which maps into my LED display. This one is bit 2 is A7. So that's 2 to the second in R6 maps to A7 in my display code. So now let's just keep adding. So let's see, now I'm gonna test bit 3. So that's the 2 cubed value, which is this one right here in R6, which if I convert that into hex is 0x, what is that? Why am I all confused? Oh, okay. No, I'm okay. That's 8. So hopefully everyone's sort of keeping that straight in their head. So R6, I'm testing this bit, which is 2 cubed, which is 8 in that nibble. So that's the 0x8 bit. Then I use an if-then clause, which you hopefully, if you did the homework, you know what that is now. Not equal means that this bit was set in R6. So if this bit is set in R6, then I need to turn on one of my display bits. That is, bit 3 is A8. So let's go work that one out. 4, 8, 9, 10, 11, 12, 13, 14, 15, 16. Bit 3 is A8. So don't care about 0. Don't care about any of those. I don't care about any of these either. So 2 to the 0, 2 first, 2 squared, 2 cubed, 2 to the 4th, 2 to the 5th, 2 to the 6th, 2 to the 7th, 2 to the 8th. That's bit A8. And then I'll zero out the rest of that nibble. So my O-ring value is 0x, 0x, 1, 0, 0. So 1, 0, 0. And if you see me make a mistake, please help me out. I'm still working in R3 for the display data because I'm still in the A's for display data. So R3 is my A pins. So what this means is if that bit is set in R6, then turn on an LED in my A bank. I know it's feels terribly confusing at first, but it's just mapping a bit from one place to another. So I map a bit that's on in R6 into a bit that's on in R3. And I'm careful to map to the bit that will cause the desired LED to come on, which is A8 in this case. Okay, so, well, before we do any more, let's try it out. So I'm gonna save that. What should happen now with R6 being 15 is 4 bits should flash. So compile or assemble. Let me clear and redo that. So assemble elf bin flash. There's the jolly good, so I'll press the black button. And the first 4 LEDs are flashing, so that's exactly what I wanted. Okay, so let's proceed. So I'm just going to keep ramping up R6 here. Now that I'm getting this high in binary, it's less convenient to translate this into decimal in my head. So this is 0x1f. So that's what I'm going to use for my counter. So back up to line 85. 85? Yeah, 85. I'm going to start using hex now because the translation process I find easier. Whatever that is in decimal. Doesn't really matter. That makes the bit pattern that I want. So back down to 126. That's the bit pattern that I want because I intend to then test this bit for the next piece. So test R6 to see if that bit is on. I'm ignoring that nibble. I don't care about that stuff anymore. I'm just worried about that one bit, which is this one right here. Hopefully that makes sense. So if that bit right there is set, then I'll do stuff. If then not equal is how I test to see if it's set. And then here I just check. I'm on 2 to the 4th, and that's A9, so I'm still in the A bank. And then A9, so let's see what that one is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I know the first 2 nibbles are all zeros, because that takes me up to 2 to the 7th. I don't care about 2 to the 8th. I do care about 2 to the 9th. And then finish off that nibble. So bit 4 is a 9. So I'm on 2 to the 4th in R6, which is A9 for my display settings. So here's 2 to the 9th in my display settings, maps to 2 to the 4th in my counter value, which is confusing, I know. 0x, let's see, that's 2, 0, 0, 2, 0, 0. So that should turn on when I go repeat the process the first 5 bits of the display. So compile, elf, bin, flash, black button, and there's the first 5, so still good. Now let's see, so R6, I'm going to add this bit. I need to be careful here because now in R6 I'm at 2 to the 5th, and now I'm switching over to the B LEDs, the LEDs that are mapped to B pins, so I have to be careful about that. B, if I go look, where is B? Here's B. The address of B is R4. And then here's the address R4 being dereferenced. So the value of B is R5. So for the B bits, I need to be manipulating R5. Bit 5 is B8. So R5, we're switching over to R5 now. So, oh wait. So this is my new value. I'm going to go update line 85. Put that in hex, that's 3F in hex. 85, 3F in hex. Sorry, I went fast. 3F, because that's now what I'm testing. I want to program to make all those bits come on together. So 3F is what R6 is going to be, and then I'm going to come down here. I'm still testing R6, that's still where the value is. And I need to know, that would be 20. So this is where I got the bit that I'm looking at in R6, will look like that. This bit right here is the one that I want to check. Is set, then that's how that works. Or not equal, so I'm in the B bits now, so I'm switching over to R5. Bit 5 is B8, I think I saw. Yeah, bit 5 is B8. So in R5 now, I need 2 to the 8th for the mapping. So that's through 2 cubed. This will be through 2 to the 7th. So here's number 8. That's 2 to the 8th, B8. So that's the value I need to turn on. That's how I turn on the B pin that I need here. So that's 0x100 in B. Notice, by the way, that's a similar location to one of the A pins, which isn't really related. It just happens to be that way. So now, if I go repeat the process, I should have the first 6 turning on. It's the first 5 right now. So back here, assemble, elf, bin, flash, jolly good, button, and the first 6 are now hitting, so we're doing good. So this thing on line 126 I'm just using as a reference point for myself. So now I want to see what happens if I make R6 be that value. Then I should see I should see 7 of my LEDs lit up. So that value is what? 8, so it's 4 and 2, 7, 7F. So I'm going to go up to 85, make the counter be 7F. I'm still in the B's. I'm on 2 to the 6th. This is 2 to the 6th. So that's B9. Okay, so test. Still testing the bits in R6. I want to know this one. So that is 40. That means successful test. Means the bit was set, in fact. So now I need to hit one of the B pins. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Bit 6 is B9, I hope. Yes. Where did it go? Here it is. Bit 6 is B9, so I don't need any through 7. Don't need 8. I do need 9. Okay, so that value in hex for the LED output is 200. Then I'm going to go build it again. I'm just clearing the screen, by the way, so you can, so it's up at the top of my terminal. Assemble / compile. Elf, bin, flash, jolly good, black button should be the first 7. So perfect, that's what I want. And then the last one for just getting the LEDs mapped in to the R6 bits correctly. So I'm at line 126. So now I want to see what happens if R6 is that. It should cause all the LEDs to light up. Way easier to do this as hex. So when I go up to line 85, I would just say make that FF. All the bits are turned on. On the way back down, I'll notice that B7 or bit 7 of R6 maps to B10 of my LEDs. Okay, so should be the last one before we can move on to the counter bit. If 1, 1, 2, 3. So now I'm testing for that bit. So that's 0x80. This construct is how I know that a bit test was successful. So that means yes, that bit in that position is in fact set. I'm still in the B's, and that means I need to adjust the value in R5. This is B10, so I don't care about any of the first 7, or up to 2 to the 7th. I don't care about 2 to the 8th, I don't care about 2 to the 9th. I do care about 2 to the 10th, that's B10. So for the LED display, I need that bit pattern, that is 400. So now back to rebuild, so just clearing the screen so it maybe it's a little easier for you to see higher up. Assemble / compile, elf, bin, flash, jolly good. If you get a not jolly good there, then something went wrong. Oh, and I know this is just sort of in passing really quickly in a video, but make sure it compiles. I've put this in the Discord, which probably most people haven't read a couple weeks ago now, but if your code doesn't compile, then there's not a whole lot I can do with it. So make sure it does compile. I will not shut my video down before I've got it correctly running. So if yours isn't correctly running, then you need to go back and review the video. Okay, so jolly good black button, all 8 should be coming on. So that's the basic setup. Now the trick is to do the counterpart. So what we really want is for this display here to count up and count down and count up and count down and count up and count down. So let's set up for that. So now we know we can display bits as R6 changes. So now we need to make R6 change.